Are you looking for an amazing Python course? Well, you are at the right place. Hi, this is Mustafa, one of your instructors from Skills Build Training. And I'm really happy to announce that Skills Build Training is offering OpenCV with Python course, which includes few projects that can help you to better understand it. But why should you even take this course? Well, this course is designed in such a way that the beginners and the pros can learn from. Here's the list of all the context we will learn throughout this course, and we will just start from the very basic to very advanced. So what are you waiting for? Without any further ado, let's take you from zero to hero.
Okay, so starting off with the environment setup, the very first thing that you want to do is that you want to download the latest version of Python. So come to this python.org and from here simply go to downloads and download the latest version, which currently at the time of the recording is 3.10.4. After that, throughout this course I will be using Visual Studio Code as my code editor. So make sure to download that if you want to go along with my setup. However, you can go with Spider or PyCharm as well. Anyways, once you're done with installing Python, you need to hit command prompt and from here you want to install the OpenCV. But before that, I'll simply just run the Python command to know which version I'm running. So as you can see, I'm running the latest version, which is 3.10.4. Anyways, now to download the OpenCV, what I'm going to use is that I'm going to use this command pip install OpenCV -contrib -python. Now, why did I put contrib? I mean, you can download the OpenCV using the pip install OpenCV Python. But this contrib means contributions. It does not only install the OpenCV, but it also installs the community contributions as well. Well, this is what I like to do. You can go with the default OpenCV package as well. Anyways, as you can see that the requirement is already satisfied for this one because I've already downloaded this particular version or OpenCV contribution on my PC. And one other thing is that you need to download Numpy. Now it would be automatically installed on your PC because Numpy is actually an essential package for OpenCV. Because Numpy is a mathematical library or a package that deals with multiplication of matrices and arrays, and throughout this course in OpenCV we will be working with arrays or arrays of images or videos. After that, what you want to do is that you want to head inside the Visual Studio Code. So simply hit Windows or Command and then type in Visual Studio Code. Now in here, what I'm going to do is that I'm going to go over the extensions tab, and from here I'm simply going to type in Python. Now this is the official Python IntelliSense package, so I'm going to install this one. But there is one more thing. What I like to do is that I don't simply install this one, but actually I install this Python extension pack. This includes a lot of packages such as AutoDocString, Python, Jinja, Django and so much more. But the really cool stuff that I like about this one is the Jupyter Notebook. Now, what is the Jupyter Notebook? So if I simply create this new file over here, so I have this file, let me just type in a print statement. Now this is a simple py file, but when I started learning Python or when I started learning OpenCV, I was working on Google Colab. Now it had code blocks, different individual code blocks. Now for that, if you have installed the extension pack, you can simply run Ctrl+Shift+P, and in here if you type Jupyter, you would have this one, create new Jupyter Notebook. Now this is really cool because this provides individual blocks and you can run individual blocks instead of running the whole program. For example, I can type print block 1 and then I can create a new block, and in this block I can simply say like print block 2. Now to run any block, I can simply click on this play icon right next to the block and it will run only that block of code. So like I really like this feature of Jupyter Notebook that is like mimicking Google Colab. Anyways, another extension that I'm using throughout this course is the Code Runner. So go to extensions and type in Code Runner. This is the extension that I'm talking about. Now install this extension, and this is really helpful because every time I don't have to write this one like Python and then the name of the file python.py and then hit it to execute it. I can simply right click on it and run code by pressing Ctrl+Alt+N. That would be the same thing. So basically it is just easier and simpler to simply press 3 buttons Ctrl+Alt+N other than typing in the whole command Python and then the name of the file.py file. So these are the extensions that I am using with my Visual Studio Code for this entire course. Now after your environment setup is done, we are simply going to start off by learning how to create images in the OpenCV and Numpy library. So what you need to know is that an image is actually a set of 2D arrays. We can say like this is an array, it has some values and it is multiplied over some number of times. So this 2D array that we have represents an image with the following pixel values. Now normally an image does not have a single array, it has like 3 arrays which are known as red, green and blue. You might have heard the term RGB, which stands for red, green and blue. Those are the 3 channels for an image. Those channels actually are again arrays that represent the values of red, green and blue. In some cases an image has 4 channels. That means that it has 4 different arrays: red, green, blue and alpha. Now alpha stands for the brightness of each pixel. And by the way, if I've not mentioned it before, each individual value inside this 2D array represents the value of a particular pixel. Anyways, to create an image using Numpy library, we need to import the Numpy library. So I'm going to start off by importing Numpy as np. After that, there are multiple ways of creating a new image, but what I'm going to do is that there is a function in the Numpy library which is called zeros. What this does is that it creates an array of your desired size and sets the value to 0, thus creating a black image. So for that, I'm simply going to create a variable and I'm going to call it black because this would be a black image. After that, I'm going to type in np.zeros to initialize the values at 0. After that, this function takes in 2 arguments. Now, the very first argument is a tuple. So I'm assuming that you guys know how to work with Python, so you might have an idea of what a tuple is. If not, then I'm going to explain it to you. It is a pair of values, or it can be a pair of 3 values. Anyways, so it takes in a tuple of width and height. So I'm going to type in the width as 500. Let's just go with 400 and 400. Put in the number of channels that the image is going to have. So if I put in 3, then that would mean that the image or the shape that is created has 3 sides or 3 particular layers. For example, when we are working with Numpy library to create OpenCV images, we would type in 3 for BGR. Normally an image is represented in RGB values, but in Python in OpenCV, it is represented as BGR values. So the very first array would be blue, then green and then red. Anyways, for the very first image, I'm not going to put in channels. I'm simply going to create a single array of 400 by 400 values, and then I need to import my CV library as well. So I'm going to do import CV2 as CV. Now, there is a function in the CV library which is cv.imshow, and this takes in 2 arguments as well. The very first is the name of the window, so I'm going to call it first image, and the second is the actual matrix of the image itself. So in this case, it is going to be black, or the variable black. So let me explain it to you once more. This function imshow creates a new window and displays the matrix that has been passed inside it. Therefore, it takes in the matrix, which in case is our image black, and this argument, the first argument, is actually the name of the window. After that, there is one very crucial step that most people forget and they are met with an error, is that CV has another function which is the wait key. Now, to work with imshow, you need to have a wait key function. Now what this essentially does is that it waits for a particular key press to be pressed to exit from that particular window. If we do not set the wait key, no image would be displayed inside the window, and that newly created window might result in a not responding error. Anyways, so we can set up either a timer in the wait key as 20, or we can simply type in 0. That would mean to simply wait for an infinite amount of time for a key to be pressed. Anyways, simply save this program and run it. I've already told you that I would be using code runner to run my code. So if I execute it, you can see that a new window is created with the name first image, and the image is all black. Now the thing is that we are working with one array or one layer of array. We can work with 3 layers, but you would not get the difference if I simply put 3 over here as like 3 layers, and if I rerun the code, because they are still initialized at 0, which is the black color. However, if we run this black array or variable through a loop which runs through all the values, and if we set it equal to 0 for the first layer, 255 for the second layer, and let's go with 0 again for the third layer, what this is going to do is that it is going to initialize all the values of the second layer at 255. Now if we rerun this code, we would get green image. Now why is that? So again, let me just write a comment over here that this particular layering system works as BGR. So for the second layer, since we put 255, that means the full value, we are simply saying that okay, the blue array is 0, the red array is 0, and the green array is filled with values. Similarly, if we were to put out green plus red, save the code and rerun it, it would give us yellow. Similarly, if I give values to all of these 3 layers and exit from the window and rerun the code, I would get a white image. Anyways, that was how to create images and to show them on a new window using the cv.im.show function. In this section, we are going to draw some shapes on our image. So we know how to create a blank image. So simply create a new file and we're going to call this as draw.py. So in here, the very first step, we are already aware of it. We want to import the CV2 as CV and we want to import the Numpy library as Numpy or as NP. After that, we again want to create a new image using the np.zeros function. So for that, I'm going to call this one as black and set it equal to, or let me just call this one as image and use np.zeros and create an array of 500 by 500 and 3 layers, which is a cube. And then what I'm going to do is that I'm going to type in cv.imshow and in here I'm going to pass in my image as the name of my window and pass in my image as well, and then cv.weight key and set it equal to 0. So if I run this code, I would get the same output that we got in the previous section. But this time around, what I'm going to do is that I'm going to add in some space over here. So the very first thing that we're going to draw on this black image is we want to draw a line. So in CV, we have this function cv.line and this function takes in 5 arguments. Well, it takes more than 5 arguments, but these are the 5 arguments that are required. So the very first is the actual image on which we are going to draw. So we are going to draw on the image. And then as you can see, my VS Code is prompting us that the next argument is the starting point or PT1 or point 1. So we are going to start this line starting from the very top left corner. So we are going to input a tuple. And by the way, whenever we are working with positioning, we are working with tuples. So the starting point would be 0 and 0, 0 for the width and 0 for the height. After that, the next argument is point 2, the ending point of the line. So we can go to the center of the image by typing in 250 by 250. Now this would create a diagonal line because we are starting from the top left heading towards the middle. After that is the color of the line. So the color is also a tuple of 3 values, which is the blue, green and red. And now we already are aware of that. So we are going to simply create a line of, let's say, the green color. So that would be 0, 255 and then 0. And the last argument is thickness. So basically this would describe the thickness of the line. So we can type thickness is equals to, let's just go with 1. After that, let's simply save our program and execute it. You can see this line has been created from the very top left to the center. But again, this is a very thin line. So what I'm going to do is that I'm going to press a key to exit and then change the thickness from 1 to, let's say, 3. Save this and execute it once more. So that would give us fairly thick line starting from the origin to the very center. Now, if you want to draw a line, let's say not to the center on a straight line, so I just have to type in the height at 0. So this should give us a line starting from the very top left, going to the middle of the screen but staying at the top. So if I save this program and execute it, I will get this result on my screen. Anyways, that was, let me just add a comment over here, drawing a line. Let me just comment this line as well. And then if we move on to the next shape, we have a function to draw a circle. So let me just write it over here, drawing a circle. So we have this function called cv.circle, which is going to draw a circle for us. Now this circle function also takes in 5 arguments. The first is the same, that is the source image, which in our case is the variable image. And then the next is actually the starting point of the circle. Now, you might be wondering that a circle does not have a starting point. Well, you're right, because this point is actually the center of the circle. So let me put the center as 250 at 250, and then the next argument is actually the radius. So I'm going to have a circle of radius, let's say 60 pixels, and then for the color I want a blue circle. So I'm going to put a tuple as 255, 0 and 0. After that, for the thickness, I want thickness to be, let's say, 2. Save this program and execute it, and on your screen you will get this empty circle. Well, we have our circle in the middle of the screen in the blue color. But what if I want this circle to be filled? Well, you might think that just increase the thickness to some absolutely crazy amount and execute it once again and you might get a full circle. Well, this might work for you in some cases, but this is not the right approach. The actual approach is, if you want any shape to be filled from within the center, you type in a negative value to thickness. So type in any negative value save the program and execute it, and you will get a center filled circle. And you can also put for the thickness cv.filled. Well, this is a constant variable which actually includes a negative value. So if I save this program and run it, we will get the same result, which is a center filled circle drawn at the center of our image. After that, we have a function to draw a rectangle, and the function is cv.rectangle. Now this function again takes in 5 arguments. The first is, we know, the image. The second is actually the starting point of the rectangle. So I'm going to start this rectangle at the origin. So I'm going to put in a tuple at 0 pixel width and 0 pixel height. For this ending point, I'm going to set it equal to, let's say, 250 and 250, which is going to be the center of our image. And then we are going to go with the color. Color we want, let's say, red. So tuple of 0, 0, 255. And then for the thickness, I'm going to go with 5. And then save the program and execute it. So this is going to give us a rectangle starting from the origin going up to the center of the image. Let's try putting in a negative value over here and then executing the program. So we get a center filled circle starting from the top left coming to the middle of this image. And then to terminate this section, we are going to write text on an image. So we have multiple ways of putting text on an image. And the very common, or I should say the very basic one, is using a function which is the putText function. Now this function takes in about 7 arguments. The first is the source image, and the second argument is your actual text. So I can type in skills build, and then the next argument is actually the origin or the starting point of the image. So I'm going to start this at 0 and at 250, and then we have the font face. Now CV comes with some default font faces, so you can go with those, or you can even import your own custom font faces. So I'm going to type in cv.font. Now we have different font faces, as you can see on the screen, like Hershey, Script, Complex, Simplex, Triplex, Complex, Small, Complex, Duplex. So I'm just going to go with the simple plain one. After that, it takes an argument which is the font scaling. So if I want a text to be really big, I can go with the scale like 5. But for the sake of this tutorial, I'm just going to type in 1.0 as my font scaling. After that is the color. So if I want to go with the white text, I would type in a tuple of 255, 255 and 255. After that, we have the thickness. So I'm going to set the thickness at 1. Save this program and execute it. So here you can see that the text skills build is written over here. All there is left to do is to actually play with all of these drawing shapes and this text settings to get good at it. So let me just change the scaling up to, let's say, 3, and let me just change the font face to complex, and let's just not upscale to 3, that would be too big. Let's upscale to 2 and then execute our program. So this is our text skills build. But there's another thing that I want to show you. If we have a longer text like skills build, let's just change it to welcome to OpenCV. So now if I execute this program, you would see an error. Well, this is not technically an error, but you would see this bug that our text is outflowing from our image. Well, there is no function to stop this from happening in the OpenCV. However, there are multiple texts to stop it from happening. Anyways, that was it for this section. Now in this section, we are going to talk about how to get input into the OpenCV. So what we are going to do is that we are going to read images, read video files, and learn how to get the live feed from the camera of your computer. So we're going to create a new file. We're going to call it readimages.py. And in this file, we are going to do the trivial, which is to import CV2 as CV and import Numpy as NP. After that, what we want to know is that there is a function in OpenCV which is the imRead function. Now this function takes in an absolute path for the image that you want to read. Now as you can see in the Explorer that I have this image as pic1.jpg. So what I can do is that I can either pass in the absolute path, but since this program is in the same directory as the image, I can simply type in pic1.jpg. After that, I can use the cv.imshow to display this image on a new window in which I'm going to call as pic1, and I'm going to pass in my variable name. So the variable I'm going to declare as picture, or let me just call it imj as image, and I'm going to pass that variable in here as well. After that, again, to get the output from the imshow function, you want to have a wait key function which is going to prompt the computer or the machine to wait for a specific key press or until a specific number of time has elapsed. So I'm going to go with 0 and then execute this program. So this is the picture that I had stored. So this is how you read pictures using the OpenCV. Now you can combine this reading with the previous section on how to write and draw text, and I can do something like cv.putText, and then I can write the text as image, I can write the text as hello, and for the origin I can go with the tuple, and for the width I'm going to type in something like 300, and for the height let's just go with like 480, because this particular image is in the dimensions of 773 by 500 or by something around that figure. And for the font face, again I'm going to go with the default one that comes with the CV. I'm going to go with complex, and for the font scaling I'm going to go with 1, and then for the color I'm going to go with a black color, so I'll actually just go with a blue color, so that would be 255 0 and 0, and then for the thickness we are going to go with a thickness of 2. So if I just save this program and execute it, on my screen I would get this hello right over here. So that is how you can combine putting up text on an image and reading an image from your computer and experiment with it. Anyways, I'm going to simply comment out this line. After that, what we want to do is that we want to input a video. So I'm going to create a new file and I'm going to type in as readvideo.py. So in here, let me just quickly write these in. Now for the video, we have a different function. Normally you would see this function, which is the read image. Because it only says I am read, you might think that this function can be used to read a video, but that is not true. To read a video, there is a function which is the video capture. Now this video capture function is very unique because it can be used to get the video locally from your storage, or you can get a live read from your camera. To get the live read from the camera, you have the arguments as integers. Like if I put in 0, that would normally mean the image from my webcam that has been connected to my PC. Now if I change this to 1, that would mean the next camera that is connected to my PC, and 2 would mean the next camera after that connected to my PC. So that is how you read live videos from your webcam, but we are going to explain that in little more detail. But currently we want to read this video file, so type in the path video.mp4, and then again we need to store it inside a variable, so I'm going to call this variable as my video. Now there are multiple ways of viewing a video on your screen using the imshow function. Now one way of doing that is to display each individual frame of the video using the imshow function. So for that we want to create a while loop which is going to be true all the time. Now within this while loop we are going to set up two variables. The first is true and the second is going to be our frame. And what we want to do is that we want to get the next frame. For that we have this function video. By the way, video is the name of the variable that in which we have stored our video file, and then read is the name of the function. Now this is going to, let me just add a comment over here, read next frame. After that, while staying inside this while loop, we are going to type in cv.imshow, and in here we are simply going to pass in the window name as video, and we are going to pass in frame because the next frame that is read is stored inside this variable frame. After that, we want to have an exit statement. So for that, type in an if command and type in if cv.waitKey is equal to 0, which is if any key is pressed, then exit from it or exit from the while loop. Now outside of this while loop, we want to do two things. First of all is we want to release the captured frames. So for that, type in video.release. And then we want to destroy all of the open windows. So for that we have the command cv.destroy all open windows or all windows. So after that, simply save the code and execute it, and you would get this still frame on your screen. Now why is that so? Now this is because we have set the weight key to 0. We need to change this to 20 or any other number, and then we need to add in another condition which is going to be a specific key press. So for that, type in 0xff and check it against the order of any key that you want. Let me just put it up as X. After that, if I save my program and execute it, my video would be able to play. So anyways, that brings us to the end of this section. So this section is going to be pretty small. In this section, we are simply going to learn how to get the live frame from a webcam or any other camera that is connected to your PC. So it is going to be pretty similar to the code from the previous section. So as you can see on my screen that I've imported the libraries. So I'm going to create a new variable, I'm going to call it video, and I'm going to set it equal to cv.videoCapture. Now I've already told you this in the previous section that if you want to get the feed from a webcam or any other camera connected to your PC, you need to input integer values into this function. So generally, the integer value 0 stands for webcam connected to your laptop or your desktop. So I'm going to put in 0 and go on with the code. After that, we know how to display a video. So even if you want to display the webcam stream, you would do it the same way you did in the video section. So it's going to be while true, then create two variables, one for the frame, and then we do video.read to get the next frame. After that, we do cv.imshow, and in here we do a window. I'm going to call it camera feed, and then we pass in the frame. After that, we need to have the wait key function and as well as the exit statement. So we do cv.wait key, we set it equal to anything other than 0, and then we add in another condition, and the condition is 0xff, which stands for a particular key order, and we test it against the order of a particular key. In this case is going to be X. After that, if this is the condition, then I'm going to break away from this loop, and outside of this loop I'm going to say video.release and cv.destroy all windows. So now if I execute my program, I should see on my screen the webcam feed. So that is how you get the input from your webcam. Anyways, in the next section, what we're going to do is that we're going to learn how to rescale images and to resize them as well. And moreover, we're going to learn how to flip this webcam video along the horizontal axis and along the vertical axis as well. So see you in the next section. So now in this section, we are going to learn how we can resize and rescale images as well as videos. So the very first thing is that why should we resize images? Now generally when we are working with OpenCV or other some kind of image processing, we usually downscale the image so that we can have faster processing and faster performance. Anyways, in CV we have this function known as cv.resize. Now this function takes in three arguments. First is the image frame. The second argument is a tuple of width and height, and the third argument is interpolation. So keeping this in mind, we are going to define a function and we are going to call this function as resize. Now this function would take in the image, or I should say the image frame, and a scaling factor on which to scale. But for the sake of this tutorial, I am going to set this scaling factor to a constant of half of the original size, which is going to be 0.5. After that, what we want to know is that every image has a shape array. Now what is this shape array? So basically, this shape array actually defines the shape or the layers of each image. Now at the 0th index, we have the height of the image, and at the first index, we have the width of the image. So what we can do now is that we can say that height is equals to get the height from the image, which is going to be the 0th index, and multiply it with the scaling factor. Similarly, we do width is equals to get the height from the image, which is going to be on the first index, and multiply it with the scaling factor. Now this equation, image multiplied by scaling factor, can result in a floating variable. So what I'm going to do now is that I'm going to create an explicit typecasting like this. After that, I'm going to create a tuple based off of these new height and width values. So I'm going to create a variable named as dimension, and I'm going to set it equal to a tuple of first width and then height. Now the reason why I took width first and height second, because the function cv.resize takes in a tuple which has width first and then the height, and then I can simply return cv.resize, which would take in the frame, which in this case is our image, and then the dimension tuple, and then the interpolation, for which we are going to use the CV predefined constant like inter area. So what this function is going to do is that it is going to take in an image, it is going to resize that image and return that resized image back to the caller. So now what we can do is that we can create a variable named as image, and we can set it equal to cv.imRead and then read the image that we currently have, which is the pic1.jpg. After that, we're going to create another variable and we're going to call it image.resize or image_resize and set it equal to the resize function, and in this resize function we're going to pass in the original image. After that, we are going to display the output. So we note that we have the function cv.imShow, and in here we're going to call the window as original image and pass in the image variable, and then we're going to call in another cm.imShow function, and this time around we're going to call the window as resized image and pass in the variable as image underscore resized. And then we want to have a cv.wait key function so that we get some kind of display on our screens. So this is going to display us two windows. So if you execute this program, as you can see that we have two different windows opened on our screen. One is the original image with the original dimensions, and one is the resized image with the changed dimensions, which actually is the half of the original dimension. Now here comes a really cool part. This function that we have defined can be used to rescale or resize videos as well. So to display that, I'm simply going to comment out this whole area. Actually, I'm going to add in a tag over here saying that resizing image, and in here I'm going to say resize video. So now I'm going to do is that I'm going to create a video variable and I'm going to set it equal to cv.videoCapture, and in here I'm going to pass in the path of my video file, which is the video.mp4. After that, we're going to create a while loop, set it equal to true, and create two variables, success and let's call it frame, and set it equal to video.read function, which is going to read as the next frame. After that, we can simply do cv.imShow and call it original video and pass in the frame in here. After that, we're going to create another variable and we're going to call it frame underscore resized, and we're going to set it equal to the resize function that we created for the image resizing, and in here we're going to pass in our original frame. After that, we're going to call cv.imShow once more to display the window name as resized video, and in here we're going to pass in the variable which is the frame underscore resize, and in here we're going to set the cv.wait key function to some non-zero value and then add in another condition which is the 0xff, which checks for a particular order of key press. In that case, we're going to break away from the loop, and what we're going to do is that we're going to say video.release to release the captured video, and then we are going to do cv.destroy all windows. So this function that we created to resize images to half of their original dimension is going to work for videos. Now why is that so? Now remember when we talked about reading videos, what we do is that we reach each individual frame. Now a single frame is a still image. So that is how we can use this function for rescaling videos as well. So now if I simply press Ctrl+Alt+N to run my code, you would see two windows on my screen. One is the original window and one is the resize window. Anyways, that was it, how to resize videos and images using OpenCV. But what if I want to rescale the stream that I get from the webcam or any other camera? So can I use this function? Well, this function can be used for images and videos but not for the webcam. For that, we have another way of doing that. So let me just comment this whole out, and now I'm going to create another variable. I'm going to call it camera feed, and I'm going to set it equal to cv.videoCapture, and we know we need to pass in the integer value as 0. Now I'm going to define another function which is going to be resize camera. Now this function is going to take in two arguments, which is going to be the width and the height. Now in here we can use a function which is the set function. So for that, we need to type in a variable name which is camera feed.set. Now in this function, the very first argument is going to be the value that you want to change. So 3 stands for width. So in here I can say 3 width, and then I can simply copy paste the same line and say 4, which stands for height, and pass in the variable height. And basically that's it. And then we can use the same way of displaying the video. But before using the cv.imShow function, we're simply going to call the resize camera function, and we're going to pass in some kind of values like 200 by 200. After that we can do cv.imshow, the normal way of displaying a video. So that is it. So now if I save my program and execute it, you would see that I get my camera feed, but as you can see, it is only 200 by 200 dimension. So I can change it by simply exiting from it and then changing it to 30 by 50 and execute my program. So I get this output on my screen. You can use this function to change videos as well or to rescale videos as well, but you cannot use this function to rescale images and normal videos. This function can only be used for live stream from webcams and connected cameras. Anyways, that was it for this section. Up until this point, what we have done is basically getting some inputs in different forms like images, videos, and live feed from the camera, and we have learned how to display that input onto the screen. And we have even performed some kind of rescaling and resizing, but other than that we have not done anything. So from this point onwards, we are going to focus on these 10 things as you can see on your screen. So the very first thing is resizing and cropping on image, then color convergence, blurring on an image, edge cascading, dilation of cascaded images, determining contours on an image, splitting layers of image into RGB or BGR in OpenCV, bitwise operators or bitwise operations, plotting a histogram of an image, and then masking. So these topics are arranged from basic to advanced, and after these topics are done, we would move on to face detection and some projects for OpenCV. These topics can be called as the fundamental functionalities of OpenCV. So let's start with the basic one. So as you can see, I have a file named as basic functions, so I'm going to do the trivial. After that, I'm going to simply read an image. Now in this section, the very first thing that we are going to learn is resizing and cropping. But you might be asking yourself that we have gone over resizing. So yes, we have gone over resizing, so I'm not going to spend time explaining what resizing is. So I'm just going to write it over here like resize and cropping. We know that cv.resize gives us the resized image. In here we have to pass in the image and the tuple of dimensions that we want. So what I'm going to do is that I'm going to take the image dot shape and take the first index and multiply it with, let's say, 0.5, and I'm going to convert it into an integer. Then I'm going to simply copy all of this and do it for the height. After that, for the interpolation, I'm going to go with cv.interarea. But before that, I want to dive in the options that are available in the interpolation argument. So basically, as you can see that we have cubic, nearest linear, area, land cause, and much more. So what are these? So basically, when you're trying to downscale an image, or maybe I can put it in this way, that when you want to reduce the size of an image, you choose the interpolation area. But in case if you're trying to upscale an image or increase the dimensions of an image, for that particular case you want to go with either linear or cubic. Linear results in pretty good images, but cubic provides the best quality for upscaling an image. But remember that with quality comes great processing. So cubic for that reason is the slowest out of all of these. Since I'm trying to reduce the size of my image by half of the original dimension, so I'm going to go with inter.area. So after that I can use the cv.imshow to display that image, and for this one I'm going to type in resized image, and I can pass in image underscore resized. And by the way, I still need to create this variable, so I'm going to copy it, go in the above line, paste in and set it equal to our cv.resize function. And just to compare all of the functionalities that I'm going to perform on this image, I'm going to type in cv.imshow and I'm going to display the original image as well. And lastly, I just need to put in cv.wait key. You know how it works now. So if I run this code, you know what would happen, that I would get two images on my screen. Good. Now let's move on to cropping. So let me just put it over here, cropping. As I've already told you that images are actually arrays of different channels representing green, blue and red. So if I want to crop a specific part of an image, what I need to do is that I need to get certain values from that array. So I can simply say like image cropped is equals to the original image, or I can just go with the resized image. Let me just go with the original image, and within this square bracket what we're going to do is that we're going to slice the arrays. So to do that, simply type in the starting index. So this is my starting point at 50 width and 200 height, and I'm going to go up to 200 width and 400 height. After that, I can simply do cv.imshow, and then I can type in cropped image for the window name and pass in my variable, which is the image underscore cropped. Save my program and execute it, and you would see that I get 3 windows on my screen. So this is the cropped image, which by chance is actually the face of the dog. This is the resized image, and this was the original image. Moving on. Next up we have something called color conversions. Now the most prominent or the most popular color conversion is actually from BGR, which is the layering system of OpenCV, to gray. So what we're going to do is that first we're going to convert a BGR image into gray. So for that I'm going to create a new variable and I'm going to call it gray, and I'm going to set it equal to cv dot. Now this is the function, which is this CVT color, which stands for convert color. In here, the very first argument is the actual image, so I'm going to pass in my original image. After that, we need to pass in the conversion code. So we have cv dot, after that we have all these conversion codes. So type in color underscore, and then you would get all of these conversions. For example, if you want to convert this image into gray, which we are going to do right now, you type in BGR2 numeric 2 GRAY. That stands for blue, green, red to gray. After that, we can simply again use cv.imshow and then create a window named as gray image and pass in our gray variable. Save the program and execute it, and you will get on your screen a grayscale image. Now the thing is that we can perform a lot more conversion than simply converting an image into grayscale. So for example, if I want to change the coloring scheme from BGR to RGB, so I can simply create a variable known as RGB, and I'm going to call it image, RGB image, set it equal to cv.cvt color, convert color, pass in my original image, and use the conversion code as cv.color underscore BGR, which is my conversion right now, to RGB. So what this is going to do is that it is going to replace the values in blue and red array. So if I cv.show and then create a window as RGB image and pass in my RGB variable, save my program and execute it, I would get this sort of distorted image on my screen. This is because we have simply replaced the values for red and blue with each other. So that is why I get this somehow weird looking filter. Now there are a lot of conversions still available. So I'm going to create a generic variable. I'm going to call it, let's say, color converted image is equals to cv.convertColor function, pass in my image variable, and then choose cv.color underscore BGR, which is my current layering scheme, to let's say HLS. After that, I can simply do cv.imshow again. I can say HLS image. For the second argument, I can simply pass in my color converted image. Then save my program and execute it, and I would get this very weird looking HLS schemed image. Anyways, that was color conversions. After that, we are simply going to split the layers of the image. We are just going to get the individual red, green and blue layer. So splitting layers of an image. In CV, we have a very basic function called cv.split. In here, we have to pass in our original image. But this function does not return a single value or a single array. It actually returns 3 arrays. The return values depend upon the number of layers that the image has. So since we know that this layering scheme works on BGR, so first B and then G and then R. So these are going to be our array variables that are going to store blue array, green array and red array. After that, we can use image.show and we can call it blue and B, and then copy it twice. So for green, we can simply use the G array or the G variable, and after that we have red. For that, we are going to use the R array. So the output is becoming quite congested. So because of that, I'm going to comment out the cv.imshow commands except for the original window. After that, I simply need to put in CV over here. So now if I save my code and run it, you would see that I have 3 different images and they are slightly different. Now they may seem grayscale to you, but they are not grayscaled. These are the values or the intensities of each different array or each different layer. For example, this is the intensity of each blue layer. In this picture, a white pixel means totally blue and a black pixel means an absence of blue. Similarly, same goes for the green one and same goes for the red one. So that is how you split an image into each individual layer. After that, let me just comment out this whole section. After that, we have some quite vast topics, but we are just going to touch them in this section. After that, when we move on to the advanced functionalities, we are going to explain them in detail. So starting off, we have the edge cascades. Now, we are going to work on edge detection, and in that section we are going to define what are the functions and what are the steps that are performed in that function. So, edge cascading. Now for edge cascading, we have a function in CV called cv.canny. Well, there are actually multiple functions to detect edges, but cv.canny is the most used function. So what I'm going to do is that I'm going to create a new variable and I'm going to call it edge image and set it equal to cv.canny. And this function cv.canny, starting with the capital C, takes in about 3 arguments. First is the original image and the second is the threshold 1, which is the starting point of the threshold. So I'm going to set it equal to 145 and the last is the threshold 2. So let's just go with 125. After that, you have much more arguments like gradients and much more apertures and stuff like that, but they are not required. After that, I can get the output using cv.imshow, and in here I'm going to call this window as edge cascade and passing my variable, which was the edge image. So save my program and execute it, and you would see this particular image. Now as you can see, this is outlining, let me place it right next to the original image. So this is outlining all of the edges that can be found in this particular image. Now there are quite a lot of edges. So let me just do this one thing. As you can see over here in my Explorer, that I have another image known as the city.jpg. So I'm going to simply change the path to my image from pic1 to city. After that, I'm going to run this same exact code. And in here I get this an image of a city, and this is that city with edges mapped out. Now, this image contains a lot of noise, a lot of unnecessary information. Maybe we do not want all of these edges. Maybe we want less edges. For that, we have something called as noise reduction. Now, noise reduction can be done through blurring. So let me just first describe noise reduction to you or blurring to you by changing it to pic1. And then in here I'm going to type in blurring. Now the very basic blurring that you can do in OpenCV is Gaussian blur. So I'm going to create a variable known as blur image, and I'm going to set it equal to cv.Gaussian blur. Now this Gaussian blur takes in 3 arguments. First, as we already know, is the original image, and the second is a tuple. Now this tuple is the kernel size, or I should say the particular shape of the kernel on which it is going to apply the blur. So I can go with something like 3x3. You can also call it the intensity of the blur, by the way. And after that, in the third argument, we need to pass in the border rule. So I'm going to go with cv.border default. You have a lot of constants that you can go with, like border constant, default, isolated, reflect 101, and so much more. But for the sake of this tutorial, I'm going to keep it simple and go with border default. After that, I'm going to simply show the blurred image. So cv.imshow blurred image and pass in my variable as blur image. Now as you can see, let me just remove this one. So this is my original image and this is my blurred image. Now you may not feel the intensity of the blur because I have set it equal to 3x3, but there is still some kind of noise reduction. Now this image is very sharp and this image is pretty much smooth out. If you cannot understand the difference, try looking at the face of the dog. So in this original image, you can see all of these details, all of this sharpness, And if you come to this blurred image, you can see that the ear or the hair on the ear has been smoothed out. To make it much more prominent, I'm going to increase the kernel from 3.3 to 7.7. So now if I save my program and execute it, you would see a very clear blur. So let me just put it right next to each other. This is the original image and this is the blurred image. Now, how can this sort of sharpness reduction or noise reduction help us in detecting less edges? Let me just show you. So as you saw that our city image was pretty big. So the very first thing that I'm going to do is that I'm going to resize my image, or I'm going to use the resized image right over here. So I'm going to pass in my city image, and as you can see that we have already resized it in this variable. So I'm going to scroll down. I'm going to remove this one and this one. And I'm going to create a new comment calling it less cascade detection using noise reduction. So in here what I'm going to do is that I'm going to create a blur image and I'm going to call it city so that I can distinguish it from this line. And I'm going to set it equal to cv.gaussian blur my image underscore resized, which I'm going to take as my original image now. And then I'm going to pass in the blur kernel, which is going to be 3.3. After that, CV border constant default. After that, what I will do is I'll actually use the canny function on both of the images, on the resized image and on the resized blur image. So let me just call it canny1 equal to cv.canny and pass in my image, pass in the threshold 1 to 5, 1 to 7. Let's just go with it. After that, we go with can2 and cv.canny and blur city image or blur image city. Oh, and by the way, I needed to change this one to image underscore resized, and I'm going to pass in the same threshold 145 and 127. After that, I'm going to go with cv.imshow, call it canny1, pass in can1, duplicate it, call it canny2 and pass in can2, and then save my program and execute it. So now this is our original image. This is not the resized image that we're showing, but that's okay. We need to focus on the edge detection ones. So now you can see that this is the image that we got without blurring. It contains a lot of detail, a lot of noise as well. Maybe we do not want all of these edges, maybe we want less edges, maybe we want just the outline of the buildings and not the windows and stuff like that. In that particular case, we would consider all of this information that is being displayed on this image as noise. So to remove this noise, we have used a Gaussian blur, and as you can see in this middle tower that the noise is way much lesser than the original image. So that is how you can use Gaussian blur as a noise reduction function for edge detection. Anyways, next up we have something known as the dilation of image. Now to display this function, we are going to use this image that was a canny, and not just the normal canny, we are going to use the canny2 which was noise reduced. And let me just change it to show only the resized image and maybe not the original image. So we are going to create a variable and we're going to call it dilated image, and we're going to set it equal to a function which is the cv.dilate. Now this function takes in 3 arguments, and we know the very first is the image, and in this example we're going to use the canny2 image, so I need to pass in the variable can2. After that we have the kernel once more. So we are going to define the kernel at 7x7, and after that we have the iterations. How many iterations do we want to run on this particular image? Or maybe we can say that how many iterations of this particular filter that we want to run on this image. So I'm going to set the iteration at 1 to start off, and then cv.imshow, and we call it dilated image, and passing the variable dilated image. After that, I need to simply save my program and execute it. So let me just remove this original image from the screen. So this was on the right our image after reducing the noise and cascading the edges, and this is the dilated image. There is only one prominent thing, that the edges are much more thicker than the one on the right. So to make it more prominent, let me just remove this by pressing a key. Let me just change the iteration to something like 5. After that, rerun the code, and this time around you would actually notice a big difference. Although it makes no sense to use this kind of iteration, but now you can at least notice the difference. So let me just go with a suitable number like 2, rerun it, and this is much more workable. After that, we have something that is directly linked to dilation, so that is erosion or eroded images. So what this actually does is that it removes the dilation from an image. We can call it the reverse of dilation. Now for this we are going to create a new variable, and we are going to call this variable as eroded_image, and we are going to set it equal to cv.erode, and this function again takes in 3 arguments which are the exact copy of the dilate function. So we have the image. Now since we want to de-dilate an image or do the opposite of dilation, we are going to take a dilated image. So dilated image is the variable that we are going to use. After that we have the kernel, and since we want the original edge detection back or edge cascading back, so we are going to go with the same kernel and the same iterations. So let me set it equal to 2, save my program, use the cv.imShow function to display it, and we are going to call it eroded image and pass in our variable for eroded image. Save my program and execute it, and you can see the 3 pictures. Let me just arrange them really quick. So this was our original image on which we applied the edge cascading and we got this result. After that we did some dilation and we got this thick edges, and on this particular dilated image we performed erosion and then we got this image. Now if you compare these two are pretty much similar to each other. That is because we use the same arguments that we use for dilation to reverse the process of dilation. Anyways, that was erosion of an image and dilation of an image. Now that also brings us to the end of this section, because from now on we are going to learn masking and plotting an histogram of an image, and after that we are going to jump inside the edge detection and the blurring in a much more detailed manner so that we can move on to face detection, and after that we can go on with some projects. Anyways, see you in the next section. In this section, we are going to learn how to plot a histogram of an image. But before that, we must answer the question that why we want to plot an histogram. So basically, the main reason for plotting a histogram of an image is to know the value ranges of pixels, or for the majority of pixels. So to calculate the histogram of an image, in CV we have this function cv.calculateHist. Now this function takes in quite few arguments. So the very first argument is actually an list of images. After that we have the list of channels, and after that we have masking or a mask. After that we have the hint size, and lastly we have the ranges for each pixel value. So that is the function that we use to get the histogram of an image. And to plot that histogram we can use multiple libraries, but the most commonly used package is the matplotlib package, and specifically it is the matplotlib.pyplot. So we include it as PLT. Now you might get an error that matplotlib is not a package in your local file or local folder. So in that case, what you want to do is that you want to come to the terminal and type in the command pip install matplotlib and then hit enter. Now as you can see that I have already satisfied the requirement, so I don't need to worry about reinstalling matplotlib. So I can simply clear up my terminal. So coming back to our tutorial, we know that each image has generally 3 channels, which is the RGB, but in OpenCV it is represented as BGR. Now what we can do is that we can learn how to plot the histogram of BGR images and grayscale images. So that is what we are going to do. Now to plot a histogram, the very first thing that is required is the image itself. So what I'm going to do is that I'm going to say image is equals to cv.imRead, and in here I'm going to type in pic1.jpg. After that I'm going to type in a variable gray is equals to cv.convertColor, and then I'm going to pass in my image and set it core to cv.colorBGR2 to gray. After that what I'm going to do is that I'm going to come to my grayscale image section, and then I'm going to create a variable hist, and I'm going to set it equal to the function that we have discussed, which is the calculateHist function. And in here, since we have already one image, so we're going to pass in that image in here as a list. And since we are working with only one channel, that is the grayscale channel, So in the list for channels, we can simply pass in 0, which would mean the 0th index. After that, for masking, we're going to pass in none for now. Now the reason for passing none in the mask section was that we have not learned masking yet. We are going to learn masking in the next coming 2 sections, where we will discuss bitwise operators, and then we learn how to use bitwise operators to create a mask of an image. So for the hint size, we are going to pass in the maximum size or the maximum value of our pixel, which is the 256. And for the value ranges, we are going to pass in value ranging from 0 to 256. So this is going to give us our histogram inside this hist variable. Now to actually plot that histogram, we are going to do plt.figure. So this is going to plot a figure. After that, what we're going to do is that we're going to set the title of this figure as plt title. And in here we're going to say something like grayscale histogram. And then we can set labels to y-axis and x-axis. So for the x-axis, we are going to say plt.xLabel is equals to value of pixels. And similarly, we can use a function which is plt.ylabel and set the label equal to number of pixels. After that, we can also set some limits to y-axis and x-axis. But in this case, we can only set values to the limit over the value of pixel. So we can use the function plt.xlim, and in here we can pass in a list of limit actually, which is going to be 0 to 256. After that, we are going to do plt.plot, and in this function we pass in our variable hist. After that, to actually display the histogram onto our screen, we do plt.show. After that, we can simply save our program and execute it. But before executing it, I want to display my image that I'm using for the histogram. So I do cv.imshow, and then I pass in my gray image. And for the window name, I'm going to say image. And we know whenever we use something like this, we need to do cv.wait key to save my program and execute it. And this is the output that we get. So we have our main image and we have our histogram. So as you can see on the image, that this image is quite bright. I mean, the dog itself is kind of on the white side. So that is why the values towards 255 are much higher, or the quantity is much higher. We can even check out the peaks by simply dragging our mouse to the peak, and we get on the bottom right x is equals to 87.1 and y is equals to 3091. What this means is that there are 3091 pixels with the value 87.1. Similarly, we can check the other peak, which is towards white. Now the value is x is equals to 175.1, let's just say 175, and y is equals to 3151. So this means that there are 3151 pixels with the value 175. Similarly goes for this peak, and all of this whole histogram. So we can choose any area or any specific point. Let's do this one. So on this point, the value 142 is repeated by 2116 pixels. So that is how we use the histogram to learn the values or the value ranges of most of the pixels. So I can simply quit from it. And after that, we can move on to the next section, which is to learn how to get the histogram of BGR image. So for this one, we don't need the grayscale, and we can show the original image, and we can comment out this histogram section, and actually we can simply comment out this whole section. So for BGR histogram, we are going to again create a variable hist is equals to cv.calculate hist, and in here we're going to pass in our original image. And for the channels, what we're going to do is that we're going to create a new variable, and we're going to call it channel is equals to a tuple of 3 characters, which is going to be B and then G and then R. And after that, what we are going to do is we are going to include this histogram function inside a for loop for each individual channel. So we can say for I, which is going to be our iterator variable, and then we can also loop through the channels in enumerate, and in here we can pass in our list, which is channels, and in this particular list we are going to include this function. So simply include it inside the for loop by simply indenting it, and then for the channels we can simply pass in I over here. After that, for the mask, we know we are going to go with none for now, and again 256 for the hint size, and range is 0 to 256. Now, what we want to do before this for loop is that we want to create this whole section. Let's actually do this one as well. And we are going to uncomment it out. And we're going to change the title from Grayscale Histogram to, let's say, BGR Histogram. And after this histogram function, we are going to call plt.plot, and we are going to plot histogram in each iteration of the for loop. And then after the for loop, we can do plt.show. Now, since up here we are doing this cv.imshow, so at the end of this whole program, we want to include cv.wait key. So simply save this program and execute it. And now on your screen you got this histogram for BGR. Now let me just show you something cool. While plotting this histogram, we can also do this thing. We can also pass in another argument, and we can call this argument as color, and in here we're going to pass in our channels list and save our program and re-execute it. This time around you actually get the blue, green and red colors on the histogram. So as you can see, the value of 0 for blue is for around, let's see, 25,220 some pixels. Same goes for the red, for 255 is around 15,000 pixels. And the best thing about using this matplotlib.pyplot package is that you can not only like zoom in and do stuff like that, but you can even save the histogram like this. Just click on the save icon and save it wherever you want. You can change the subplotting to go left, right, bottom. You have a lot of configuration options that come with this package. Anyways, that was all on how to plot histogram of grayscale images as well as the BGR images. So in this section, we are going to learn about the bitwise operators in OpenCV. So let's just create a new file and let's call it Bitwise Functions.py. So import CV2 as CV, and to demonstrate the bitwise functions, we are going to create some blank or black images. So for that, we know from the first section that to create new images we use the Numpy library. So I'm going to import Numpy as np. After that, we are simply going to create two images. So let's call one as rectangle. Well, actually it's going to be a black image, so let's just call it a black image. And to create it, we know that we use the numpy.zeros, and in here we need to pass in the shape, which is the dimension. So we're going to go with 400 by 400. After that, I've not shown you this before, but you can pass in the type of your image or file. So we usually go with the type which is the unassigned integer 8-bit. So it's uint8. After that, we are going to use the rectangle function to create a rectangle image. So for that, let's do a variable, call it rectangle, and set it equal to cv.rectangle. And in here, we can pass in our main image, but we don't want that. We don't want to manipulate our main image. So we can use the copy function. So this would create a copy of the main image as the source for rectangle. And in here, we're going to set up the starting points. So let me just start this rectangle at, let's say, 40 by 40. And since I have left 40 pixels from the start, so I'm going to leave 40 pixels from the end as well. So it's going to be 360 by 360 for the second point. And for the color, we can go with a white color. So 255, 255 and 255. But as you can notice over here that we have not set the channels. So we can simply go with 255 as it is working on a single channel. After that, I want a thickness of -1, so I set thickness equal to -1, so my rectangle is completely filled. After that, I'm going to duplicate this line and I'm going to change the function from rectangle to circle. And similarly, I'm going to change the variable name from rectangle to circle. Once that is done, we're going to set the origin at the middle. And for the radius, we're going to go with the radius of, let's say, let's just do 180. Let's see the result. So once that is done, we are going to use cv.imshow, call it rectangle, pass in the rectangle image, duplicate it, change it to circle, and change the window name to circle as well. Once that is done, we are going to end it off with cv.wait key and set it equal to 0 and run our program. So that is our image, and I did not place this at the center, so I'm going to change it to 200 by 200. Do that, rerun the program. Yeah, so that's much better. Now we can work with the bitwise operators. So the bitwise operators are like logical gates like AND, OR, NOT, XOR and so much more. But we are going to focus on those ones like AND, OR, NOT and XOR. So let's start off with the AND operator. So let me just type it here, AND operator. So we are going to create a variable and we're going to call it AND bit. And we're going to set it equal to cv.bitwise, and these are the functions that are available in the CV library. So bitwise and this function takes in two main parameters. So the first one is the first image, so it's rectangle, and the second one is the second image, which is the circle. After that, it takes other arguments like masking and matrices, but we do not want that. We are working with two images, so we're going to pass in those two images. And then we can do cv.imshow, call it bitwise operation, and pass in our AND bit. So let's get the output. So here is the result of our bitwise AND operator. So if you're not familiar with the bitwise operators or the logical operators, then AND is an operator that superimposes the common parts of two conditions or operators. In this case, we had two images, one was the rectangle and the other one was the circle. So what this operator did was, it only displayed the common parts of these two images, or I should say the common part where the color was white or the pixel value was set to 255, in other words 1, since we are working with a single channel. So it only showed the common part. So that was the bitwise AND operator. And an exact opposite is the OR operator. So what I'm going to do is that I'm going to copy these two lines and I'm going to call my variable as ORBIT and change the function to OR and pass in my image, which is circle and rectangle. And then in the cv.imshow function, I'm going to change it to ORBIT and also change my title. So save my program and execute it, and on screen I get this weird image. So what does the OR operator do? It shows all of the values that are true in both of the images, meaning that the bitwise OR operator superimposes both of the images and displays the output, whereas the AND operator only displays the output of the intersection of both of the images. That is why we get this weird looking Pokemon shape over here. And then we have something called the NOT gate or the NOT operator. So we're going to call it NOT bit and set it equal to cv.bitwise NOT. And this function takes only one argument. So let me just pass in my circle over here and then do cv.imshow, call my window as NOT operator and pass in the NOT bit. So if I display my result, I have this circle, but this time around this circle is black. Why is that so? So basically what the NOT operator does is that it flips the values. So if something is on, it would turn it off. So in this case, if the value was 255, it has turned it to 0. So that is why it is showing us the outer section of the circle to be white. So that is the working of NOT operator. And lastly, we have a combination of OR operator and the NOT operator, which is the XOR operator. So XOR is equals to cv.bitwise XOR and pass in rectangle, comma, circle, and then do cv.imshow, call this window XOR, and then pass in our XOR bit. So save my program and execute it, and I get this. So basically what it did was, it took the rectangle and the circle, superimposed it to form an OR gate, and inverted that OR bit or OR gate to show us this image, which shows us the part which does not intersect with each other. Anyways, these were the bitwise operators in OpenCV. Now these are very important functions when working with OpenCV, because whenever we are working with images, we use masking. So if you're coming from a graphic designing background, you know what masking is. So to actually put up a mask on an image, we need to use the bitwise operators. So that was it for this section. So let's finally talk about masking. So masking, if you come from a graphic designer's background, you know that is like putting a particular mask on an image. Now what the masking actually does is that it highlights an area on which you're going to work, or it highlights an important area on which all the other operations are going to be performed and the results are shown inside that particular area. Now to work with masking and to display the output, we are going to again use the Numpy library and we're going to get an image. Now when we have this image, we want to have a black image as well. So we're going to create a black image using the numpy.zeros function. Now there is one important step that you cannot give any dimension over here, because a mask has to be of the exact same size as of our image. So what we can do is that we create some variables and store the image.shape like this, their dimensions inside those variables, or we can simply come to this dimension and in here we pass in image.shape and then we use square brackets and pass in the first two layers. After that, what we want is that we are going to set the data type to uint8. Now we are going to create our mask. So this is going to define the area on which we are going to mask our image. So that is done by cv. Let's just go with let's do a rectangle mask. So the image is going to be the black one, and the dimension I want to start at, let's just say 60 by 60, and I want to go up to, let's go with 360 by 360. After that, for the color, let's just go with 255 and thickness of -1. So now if I do cv.imshow and show my original image, and then I do cv.show and show my mask, and then I do cv.wait key, go with 0, hit Ctrl S and then run my program, I get this mask. So now I want to display only this image. Let's actually do this one thing. Let's move this rectangle a bit to the right so I get this face of the dog. So what I'm going to do is I'm going to change it from 60 to something like 150 or 160, and then change it to 460. Yeah, something like that would work, but we can play around with that later. Now we are going to create our masked image, so we're going to call a variable as masked image, and then now this is where you create masked images. So we do cv.bitwise and operator, and then for the source images we're going to pass in our main image twice. Then we're going to set mask is equals to our mask variable, which in this case is also mask, and just to get rid of confusion I'm going to change it to mask1, let's say. So let's change it mask1 here and here. With that done, I should have a masked image. So let's do that as well. cv.imshow, call it masked, and pass in my masked image variable, and then Ctrl S and run my code. So this was our mask that was to applied on this image, and this was the result that we got. So we somehow got the face of the dog inside it. So that is how you work with masking. You can apply different shapes of masking as well. For example, let me just put up over here a circular mask. So for that I'm going to create a variable. I'm going to call it circle mask, set it equal to cv.circle. Actually, let's just change this code to black.copy so I don't mess with the original black image, and do black.copy over here as well. And then for the dimensions I'm going to go with image.shape. I'm going to get the width and divided by 2. So the center of the circle is also the center of the image. After that, for the second dimension I'm going to go with image.shape, the height parameter, and divide that by 2 as well. And then again for the radius I'm going to go with a circle of, let's just go with 300, and then 255, and then thickness of -1. Then we're going to create another image and we're going to call it masked circle image. So this is going to be equal to cv.bitwise and then in here we're going to pass an image. For the mask it is going to be circle mask. Then we can do cv.imshow circular mask pass in masked circle image and execute my program. So this is a circular mask. Now let's see how we can play around with these masks. So just imagine that you have a rectangle which starts from 160 by 60 and goes up to, let's just make it a little wide. Let's just say it goes up to 660 by 660 and it starts at, let's just change it to 60 by 60. So this is a circle and rectangular mask. And now what we can do is that we can create combination of circle and rectangle mask. So we're going to create a new variable called mask combined is equal to cv.bitwise and in here we're going to pass in mask 1 and the circle mask. Let's just not do that, let's actually do bitwise or. So that is our mask, and then we're going to create a new variable combined mask image is equals to cv.bitwise and in here we're going to pass in image comma for the mask it is going to be mask underscore combined, and then at the end we do cv.imshow and then we go with combined mask, pass in our combined mask variable and then display the output. So this is the output that we got, and yeah, it is not in the center, the rectangle is not in the center. We can mess around with the values, like let's just change it to from 60, let's just change it to 260 and let's add in 260 over here as well, or I mean 200 over here as well. So now if I save my program and execute it and end the termination of the last ones, I get this output. So my rectangle is way down on the bottom. So you can play around with that. Well, this is a good output. I was not expecting this. I got the whole dog and it's a very weird one. But anyways, that was the concept of masking and how to create masks using the bitwise operators. And then you can also combine different masks to create a third mask. So that's it for this section. Now that we have learned how to create masks, we are going to revisit the histogram section and we are going to learn how to make masked histograms. So I'm not going to create a new file, I'm just going to duplicate this one. And in here I'm simply going to comment out all of this section and add some space in it so it doesn't become too much congested. After that I'm going to uncomment all of this section, comment this section as well. So the very first thing that we're going to do is that we're going to learn how to create a mask of the grayscale image. So I'm going to pass in my gray image and then I need to import the Numpy library, so Numpy as np, then create a black image is equals to np.zeros, and for the dimensions we know it's image.shape and a loop for the first two values, and then I can set a d type equal to uint8. So this is our black image. Now inside this grayscale image I'm going to create a mask. Mask 1 is equals to cv dot, let's just go with a circular mask, and I want to create this mask on the grayscale image, so gray, and the dimensions I want to start from the center. Now we know how to do that, so I'm just going to quickly go over that. And the radius I want to keep it at 300. Let's just do a small circle, let's just do 150 and 255 and thickness of -1. So right over here is where we are calculating our histogram. We can pass in our mask 1 because this was the argument for mask. But just to display the actual image or actual masked image, I'm going to create a new variable. I'm going to call it masked image and set it equal to cv.bitwise and then pass in my gray and gray again, and then pass mask is equals to mask 1. Now remember, this is not a crucial step, this is not a required step at all. I'm just adding in this line so that I can view on which image or of which image I'm getting the histogram. After that we can simply go along with the same steps that I had. Let me just give it a new line. Yeah, so everything seems fine. So what I'm going to do is that I'm going to just simply change it masked grayscale image. So now if I run my code, you can see that this was our original image. Okay, I did not show my masked image, so let's just quit. Let's actually do cv.im show, and let's just show the masked image as well. And I need to change it from gray to black as well. That was a mistake on my part. So after that, I can simply rerun my code, and you would see that this was the original image, and this is the masked image of which we are getting the histogram, and this is the histogram of that masked section. Now, you may think that this might be the histogram of all of the image and not just this masked section, but that is not true. And you can conclude that with the following logic, that this whole image contains a lot of black parts. So if this histogram was of this whole image and not just the masked section, then the values would range highest at the value 0, because that means black. But since there are only 1400 pixels at peaks, we can conclude that this histogram is only of this particular masked section. Anyways, that was how you create masked sections of grayscale images, and the exact same method can be used for BGR images. Let me just check it out. So I'm just going to quit from my output, and I'm going to again comment this whole section out, and then uncomment this whole section out. And I want to show my original image this time. I already have my black image, so I'm going to copy this whole section, 3 lines, paste it over here. So this time around, I'm not actually going to create a mask of gray and gray. I'm going to go with image and then image once more. So this is not going to be the gray image, this is going to be the masked BGR image, and pass in my masked image variable. And in here, again, the third argument of the calculate hist function is the mask, so I'm going to remove none and type in mask1 over here. So that should do it. So if I just go with Ctrl Alt N to run my code, I would get my original image, my masked image, and the values of that masked section. So as you can see in this whole image, this is a very bright image, and the values for red are quite high. There are around 8500 some pixels with the value 255.6. That's quite red. Anyways, that was how you can combine masking and histograms to create histograms of only the masked section of a particular image. And that also brings us to the end of this very short section. So, I have completely forgotten about a section which is the image translations and transformations as well. I was about to move on to contour detection and edge detection, but I suddenly realized that I have completely missed this section, which is the image transformation. So, I'm going to create a new file and I'm going to call this file as translation.py. So, in this whole section, what we're going to do is that we are going to learn how to perform the basic image transformations. Now, this is something that lies in the basic category. However, these may or may not be useful according to your project. Anyways, so we are going to start off this section with image translation. So basically, what is translation? Translation is simply moving the image along the x-axis or along the y-axis or even in both of the axes. So let's start off by simply importing OpenCV. And in this section, we are going to be using some functions from the Numpy library. So I'm going to import Numpy as np. After that, I want to get an image, so I'm going to do cv is equals to image is equal to cv.im read, and in here I'm going to get pic1.jpg, and then I'm simply going to do cv.im show original image and pass in my image in here. After that, we do cv.wait key, pass in 0. So now basically, whenever we want to translate an image, we use the function cv.warpify. So this is the function that we use, and this function takes in 3 major arguments. First is the image, second is the translation matrix, and the last is the dimensions of the image. Keeping this in mind, we're going to create actually a function that is dynamic enough to translate all the images that we want. So I'm going to create a function and I'm going to call this function as translate image. Now this function, again, as I've already mentioned, takes in three major arguments: image, but not translation matrix and dimension, but rather the x values and the y value. So basically what this is going to do is that we're going to take in the translation amount in pixels for each axis. After that, we want to create this translation matrix, so we're going to simply call this one as matrix. Let's actually call it translation matrix. And we're going to set it equal to a list which includes two lists inside it. Now for the first list, it is going to be 1, 0 and x. And for the second one, it is going to be 0, 1 and y. So this is the translation matrix that we are going to use. However, to create this translation matrix, we need to put or wrap this around in np.float32. So simply wrap this in float32 and you would get your translation matrix. Now, we want to get the dimensions of the image. So we are going to simply get dimensions is going to be a tuple of image dot shape. First is going to be the width, so it's going to be at 1, and then it's going to be image dot shape, it's going to be at 0 for the height. After that, we can simply return our function, which was this one. So we can type return cv.warpAffine, and in this particular return statement we can pass in our image, we can pass in our translation matrix, and finally we can pass in our dimensions tuple. So that should do it. Now we can come out of this function and maybe we can simply what do? We create a new variable, translated image, and we set it equal to this function. Not translated, is actually translate image, and we're going to pass in our original image. And let's see, if I put in the values at 200 by 200 and then I do cv.imshow and pass in my, let's say, translated image, and pass in my variable which is also translated image, save my program and execute it, and I get this on my screen. So the image was moved to the right and down by 200 and 200 pixels. So that is how you do translation. But let's see what effect do we get when I change this value to 100 and 100. Let's just go with a negative value. The negative value for the x and 100 value for the y. So if I save this program and execute it, so it is being moved to the left and down by 100 pixels. And then let's do negative 100 and negative 100. Save my program and execute it, and it is being moved up and towards the left by 100 pixels. So we can conclude that whenever we put positive values, we move right along the x-axis and down towards or along the y-axis. And if we put negative values, we move left along the x-axis and up along the y-axis. So that is how you translate an image along the x and y axis. Remember that if we put positive values, we would move right along the x-axis and down along the y-axis, and if we put negative values, we are going to move left and up. So simply play along with the values and find the one that you want. So now what we're going to do is that we're going to work with rotation. So at first I was about to create a new py file for rotation, but that would create a lot of mess over here. So I'm simply going to change the name of this one, and I'm going to change it to image transformations. Now we are going to do rotations. So again, in the rotation we use this same exact function. So this is our function that we use, but rather than the translation matrix, we actually use our rotation matrix. So let's again start off by creating a new function, and we're going to call it rotate image. And this function takes the original image and then takes in an angle and the point where you want to rotate. So I'm going to call this one point of rotation. Basically this is the anchor point for rotation, so we can also call it anchor point. Now sometimes you don't want to give the anchor point because you want to start the rotation or anchor the rotation from the center of the image. So I'm going to also set a default value to this one, which is going to be none. After that, what I need to do is that if the anchor point is none, I know that I want to rotate the image from the very center. For that, I need to get the height and the width and divide it by 2 to get the middle point. Let's simply create two variables and call them height and width. And to fetch these values, I'm going to use image.shape and a for loop and a loop for the first two values. And then if my anchor point is none, then change the anchor point to width divided by 2 and height divided by 2. So that is going to give us the center point of our image. Now if we come out of the if statement, we want to create this rotation matrix, this one right over here. So we create a variable, call it rotate matrix or rot matrix, and we set it equal to numpy. Okay, it's not numpy, it's actually cv.getRotationMatrix 2D, and in here it is going to take in 3 different arguments. The first one being the rotation point. So the rotation point in our case is actually the anchor point. After that, it is going to take in a specific angle on which it is going to rotate. So pass in the angle from the function, and then it is going to take in a scale value, as you can see over here. So scaling is like if you want to scale the image while rotating it. So I don't think we want to do it because I'm just creating a function for only rotation. So I'm going to set the scale at 1.0. After that, we want dimension, and we know how to get dimension. Dimension is equal to a tuple of width and height. We already have created these variables, so there won't be any problem. And then we can simply do return cv.warpAffine and pass in our image, pass in our rotation matrix, which is the rot matrix, and finally pass in our destination dimensions. So that should give us our rotated image. So let's take the original image and let's create a variable. Let's call it rot1 because that sounds cool, and set it equal to rotate image, and we're going to pass in our original image and pass in the angle at, let's say, 60 degrees. So save my program. Oh, actually I need to show it as well. So cv.imshow and pass in our rot1, and for the window name we're going to simply say rotated image. Save my program and execute it, and this is our image rotated to 60 degrees. So if we put positive values, the image is rotated anti-clockwise. So if I try doing -60 like this one, so the image would be moved clockwise. Okay, now what if I simply change this to 90? So as you can see that the image is rotated 90 degrees. But what if I do this 90 and along with that I don't just do it in one step, I do it in 2 steps. Like I do it 45, and the other image would take in the first rotated image and rotate it by 45, and we'll call it rot2. So now if I simply show rot1 and rotation 2, let's see what is our output, and I need to change it to 45 and not 50. Save my program and execute it, and I get this image. Now although this image is rotated in 90 degrees, but still we have these black images or black shapes. Why do we have them? So basically what happens is that whenever you translate an image, it is not just simply shifted upwards. Basically all of the data that is over here outside of this particular window is lost, and when you try to translate it back, that image or that particular pixel values are at 0, so that returns in black shapes. So that is what happened over here. So basically when we rotated that image, we got some black shapes, and then when we rotated that image again, we got some more black shapes. That is how we ended up with this particular warped image. Anyways, basically if you want to rotate something like 90 degrees or 135 degrees or something like that, don't try to rotate it once and then add in the degrees and then rotate it twice and then add in the degrees and rotate it thrice. Basically just do it in one go. Anyways, that was rotation of images on OpenCV. The next thing in image transformation is actually flipping the image. So let's type in flipping an image, And flipping an image is done by a function in CV which is cv.flip, and this takes in two basically arguments, which is image and then an integer which is known as the flip code. Anyways, let's see how to do it. So we're going to create a new variable and we're going to call it flipped image, and we're going to set it equal to cv.flip, and in here we're going to pass in our original image, and for the flip code we're going to pass in 0, and then we are going to do cv.imshow and do flipped image and pass in our flipped image. So if I save my program and execute it, you can see that my image has been flipped upside down. So basically we can say that the image has been flipped along or across the x-axis. So if I change this flip code to 1, that would change it or flip it along the y-axis. So this was our original image and this is our flipped image. Now what if I want both of them? Can I go with 2? So let's try 2. So as you can see that 2 does not work for flipping an image across y and x axis. So let's try a negative value, because I know that putting a negative value flips it along the x axis as well as the y axis as well. So that is image flipping. Now when we are talking about image transformation, or if you search for image transformation on Google or whatever search engine that you like, you would come up with 4 different functionalities. One is obviously translation, then rotation, then flipping, and the last would be resizing. But we know how to resize, so I'm not going to show it in this video or in this section. So cv.resize, take an image, take a tuple of destination, and lastly interpolation. So that is how you resize. So I'm not going to show it because I've already shown this twice in this whole tutorial. Anyways, that was it for this section on image transformations in the OpenCV. So in this section we are going to talk about how to find the contours of an image. Now, you might be wondering what are contours. Well, if I tell you what contours are, you might think that they are the same as edges. So basically, contours are the boundaries of an object. Now in this section of edge cascading, we learned that how to find edges using the canny edge detector. However, contours can easily be misunderstood with edges as being the same and equal to edges, but they're not. I mean, from a programming point of view, if you're not familiar with object detection, object tracking or stuff like that, or architecturing, then for you, contours and edges are the same exact thing. But if you are one of those architects or you want to work with image transformation and more in depth with object detection, then contours are very different from edges. However, they may seem the exact same on paper. So basically, what are contours? So let me just type in here. Contours are boundaries of an object, but they can be lines as well as curves. So this is that something that differentiates them from edges, because edges cannot be curves. However, when we use the canny edge detector, we are met with some curved edges. Anyways, contours are mostly used for object detection. So if you want to head over to that field for object detection and implement some kind of CNN, which is a convolution neural networks, or maybe some RNN on object detection, then you would have to use contours, because that in that particular field is a major requirement. Anyways, so let's set up the template. Although we don't need the Numpy library for contour detection, but I'm going to display the contour on a blank image. So for that, I'm going to create an image using the Numpy library, which is exactly numpy.zeros function. So for that, I'm using the Numpy library. Let's start off with the image. And let's also create a blank image. So I'm going to call this one as my canvas. And I'm going to pass in image.shape, because my canvas should be the exact same as my image. And then I'm going to pass in the type, which is actually optional, but I'm just going to do it anyways, as unsigned integer 8. After that, now to find contours, we have this function in CV which is known as the CV find contours. And this function takes in quite a few arguments. Now the very first argument is the basis of finding contours. Now this can be canny, or this can be, let me just put up a slash over here. Now this can be the thresholding technique. So one of those as my base, and after that it takes in the mode for finding contours. Now this mode can be cv.return, and then in here you have a lot of different modes likeccomp, external, flood fill, list and tree. Well, we'll tell you what this is, but for now I'm just put it at list. And then lastly, we have the approximation technique. So approximation techniques basically either compresses the contours found to make a well-defined, organized and concise list of contours. So we can go with a simple approximation, or we can go with none approximation at all. For the starting, we are going to go with the none, as it is the default one. So let me just comment it out. Now to find contours, we are going to use the Kenny method over here, and we can also use the threshold. So I'm going to type that over here as well. And then we're going to start with Kenny, and for Kenny we know that we want a gray image, so I'm going to create a variable gray, and I'm going to set it equal to cv.convertColor and pass in my original image, and then I'm going to pass in cv.color bgr to gray. After that, we want to pass this image in our Kenny edge detector, but before that let me just do cv.imshow, and then I'm going to do Kenny is equals to cv.Kenny and pass in my gray image, and then I'm going to pass in my threshold at 1 to 5, and let's just go with 175. So that is our Kenny edge detector, and we can do cv.imshow Kenny output and pass in my Kenny over here. After that, this function cv.findContours actually returns us two different variables or two different lists. Now the first list is actually the contours list, so we can create a variable named as contours. And the second list is actually something that we do not need in this OpenCV beginners crash course, which is the hierarchies. Now hierarchies are required when you are into object detection and stuff like that. We can set it equal to cv.findContours, and then we can pass in our Kenny, and then use again cv.return. We are going to go with list, and then we are going to do, for the approximation, we're going to do cv.chain approximation none. Now let me tell you what this mod is. So basically list returns all of the contours that it can find in that Kenny image, and if you change it from list to, let's say, external, then it is going to find only the external contours of objects, not the internal ones. Now these external contours are found by hierarchies, so that is why we get this list for hierarchical structure. Anyways, after that we have the tree. Now this tree actually returns the hierarchical structure of contours, but in a tree like hierarchy. Anyways, for this tutorial I'm going to keep it simple and just go with list. After that we have our contours list. Now this is a list, that means we can find the length of that particular list. So we can do printf, and okay, it's not printf, it's actually print, and simply go length of my contours list. So that is going to print out the length of my contours, or the total number of contours that I've found in this particular image. And then what I can do is that I can actually use the cv.drawContours function to draw on my canvas. So I'm going to do cv.drawContours. Now this function takes in quite a few arguments as well. So the very first argument is the image on which we want to draw, so that would be our canvas. After that, it takes in a list of contours, so we know that our list is set inside contours. And then the third argument is the contour IDs. Basically, you can define the total number of contours that you want to draw on your image. So I can go with 500, 2000, 200, whatever I want. Or if I want to draw all of the contours that are in this list, so I would type -1. After that, it takes in the color for drawing your contours. So I can go with the BGR scheme and type in, let's just go with green contours, so 02550, and then it takes in thickness, so I'm going to type in -1. Then I can do cv.imshow, type in contours, pass in my canvas. So that should give us my contours, and at the very end we do the traditional wait key. Save my program and execute it, and I get that I have a total of 2271 contour in this image, in this grayscale image. So this was our original image, and with Kenny function we got this edge detection or edge cascading, and out of this edge cascading we were able to draw these contours. Now you might think that this is an exact copy of this particular edge detection. That may be the case because again, you can misunderstand contours with edges as they are pretty much the same thing, but if you think it from a mathematical point of view, their definition is totally different. We can try to lower down the noise in this image so that we can find better contours by either changing this approximation method to simple and then running our program, I need to exit from the output and then save our program and execute it. So that would reduce the number of contours if there are straight lines, because a straight line can be represented by simply 2 points, the starting point and the ending point. But if the contours are not straight, the simple approximation method won't be able to compress the number of contours. So as you can see in this image, there are no visible straight lines, so that is why we still got the same number. And the other thing that we can do is that we can do noise reduction by using a blur. So I can pass in my blur image, do cv.gaussian blur, pass in my image, do a kernel size of let's say 7x7, and then do cv.border default. After that, okay, I need to remove the spaces from here, save my program and execute it. Okay, actually I needed to change this from gray to blur image. After that, I can simply execute my program, and this time around I have way more or less contours. I have 400 contours, even though I did not detect the full dog. So let me just change it from 7 to let's do 5 and 5, save my program and re-execute my program. So this time around I had 1199 contours. So let's try changing the contour detection mode. So let's change it from list to something like external. So let's do that and let's try running our program. So this time around we were able to find 1148 contours. And now if we change it from external to let's say tree, save my program and execute it. So this time around I was able to find 1199 contours once more. Now what I can do is that I had another image, which is this one, which is of a city. So it contains much more like straight lines. So I'm going to pass in that image. So city.jpg, save my program and execute it. And even though it is a much bigger picture with a lot more edges, we were only able to find 864 contours. And I think that is because of this approximation method. Let me just show. So this is the canny output and this is the contours. So that is how you find contours using the canny edge detector. But there is another way of finding contours. For that we use the thresholding technique. So what we can do is that we can create two variables, because our cv.threshold method actually returns two variables or two lists. One is going to be ret, return value, and then threshold for our variable name, and we are going to set it equal to cv.threshold. Now this function is going to take in our gray image, and then it is going to take in threshold value. So we're going to start the threshold at 125. Basically we are saying that pixel intensity of 125 or more gets shifted to 255, and if the pixel intensity is less than 125, then it gets shifted to 0. Now why is that? So basically what thresholding does is that it is a process of binarizing the image. What this means is that in binary language we only have two different options available, that is on or off, 0 or 1. So basically this thresholding technique either changes the pixel value to 0 or 1 depending upon a threshold. If a pixel intensity is greater than the threshold, then it is changed to 1, and if it is lower than the threshold, then it is changed to 0. But in this case, since we cannot put simply 1, we would change it to the maximum value of each pixel intensity, which is 255. Now after that, after this pixel intensity, we need to pass in the thresholding technique. So since we are using binary thresholding or binarization, so we type thresh_binary. With this, we can pass in this threshold, or I'm going to call it threshold image. Okay, not this, actually threshold image, and then I'm going to pass in this image in our cv.findContours function. With this, I'm going to change my image to the smaller one, which is the pick one, and then save and execute my program. So this was our contours. So we were able to find 1659 contours using the thresholding technique and the threshold 1 to 5. So if I change the threshold to, let's say, since it is a very bright image, I can change it to something like 170 and rerun my program. This time around we were able to find 1302 contours, and if I change the color to something like red, so this is our contoured image. So that is how you can find contours in OpenCV. To end off this section, what we are going to do is that we are again going to pass in our city image and we are going to execute our program. So in the city image we were able to find 2427 contours. So this was our grayscale image. and this is our contours. Now if you look at it, there is a big difference between this contours and the edge detection that we get from Canny, because I remember that there was a building over here with a lot of windows, so in contour detection we did not detect that building or those images. So let's do this one last thing. Let's simply uncomment this section, pass in our Canny edge detectors output, and pass in the retrieve the external contours. With that, I'm going to save my program and execute it, and I got 815 contours, and these are all of the contours that I could find. That was the section on how to find contours in OpenCV. Again, you might misunderstand and you might not even notice the difference between contours and edges, and that is totally okay unless you want to head inside object detection in detail. So in this section, we are going to talk a little about thresholding. Basically, we use thresholding in contours, so I wanted to talk about thresholding in a little more detail. So I'm going to create a new file. I'm going to call it threshold.py, and I'm going to import CV as CV2 as CV and import Numpy as NP, get my image, and again, what I'm going to do is that I'm going to convert my image into the grayscale image. So gray is equal to cv.cvt color, and pass in my image and color underscore bgr to gray. So this is going to set up my template. So I'm going to do cv.imshow. I'm going to display the original image, and I'm also going to display the gray image. After that, when we use the cv.threshold function, we use these two variables. So the first one was threshold and the other one was threshold image. So what are these variables? So basically, when we use the cv.threshold function, it returns us two values. First is the same exact value of threshold that we put into this function, and the second is actually the image. So if I pass on the gray image and set the threshold at 175, for the mode I got cv.thresBinary. So basically, my original thresholded image would be stored in this variable, whereas this value, the threshold value, would be returned to this variable. So then I can do cv.imshow, and I can go with threshold or thresholded image and pass in my thresholded image variable. So if I save a program and execute it, I get this on my screen. So this is my original image, my grayscale image, and finally my thresholded image. So I can play with the thresholded values and execute my program once more. So as you can see, this is a little more bright. Now what we can do is that we can change this threshold binary to threshold inverse binary. So if I execute my program now, you can see that this time around the result is actually the opposite of the previous result. Basically what this inverse did was it applied a not bitwise operator and it converted the white to black and black to white. Now this kind of thresholding can be called as normal thresholding. Now there is also an option for adaptive thresholding in which you do not need to specify the value for threshold. You can get the value for threshold for each individual pixel by checking either the surrounding, which is also a method that is used in that function. So for adaptive thresholding, we are going to create a new variable, and I'm going to call it athresh_image, and then I'm going to use the function cv.adaptiveThreshold, and this function takes in quite a few arguments. The very first one is obviously the source image, and then we have the maximum value per pixel. So I'm going to set, by the way, this is not the threshold value, this is the maximum value. So I'm going to set it equal to 255, and then you have the adaptive method. So we have the following methods, cv.adaptive, and in here you can see that we have adaptive Gaussian C, or we can go with the adaptive mean C. So let's go with the mean C. So what this mean C does is that for each individual pixel, it checks its surrounding or its neighboring pixels and decides a mean value for the threshold. And this C is actually the value that is used to fine-tune that mean by subtracting it from the mean that is found by OpenCV. After that, we can choose the thresholding type. This is the same exact one as the previous function, which can be cv_thresBinary or cv_thresBinary inverse. So let's go with cv_thresBinary for the first one. And lastly, we have the block size. So basically, this would be the neighborhood that would be checked for the mean value of particular pixel. So let's set it at, let's do like 7. And then this is the C that we can use to fine tune our mean value. So let's go with 3. So now we can just do cv.imshow, and we can go something like adaptive thresholding example, and pass in our Ahrefs image. With this, if we run the program, we get the following output. So as you can see, this is a much better output for contour detection. And yes, we can combine this sort of adaptive thresholding to find out contours in an image. So we can mess around with the values to get even more clearer images or contours or edges. So let's change the block size to something like 13, and let's also change the C value to a bigger C value. Let's go with 7. And if I execute my program right now, so I get much more clearer and thicker edges of my image. We can use this Ahrefs image to find the contours as well. So if we make two variables, contours, and let's go with here for hierarchies and set it equal to cv.findContours and pass in our Ahrefs image, and then for the mode, let's go cv.retrieve, let's go with list, and then for the approximation, we are going to go with cv.chain approximation none. With that, we get the contours and our contours list. After that, what we will do is that we will create a canvas, set it equal to np.zeros, and pass in the dimensions for our original image. Actually, we do not need the square brackets. And then for the d type, I'm going to set it equal to uint8. Now this d type is actually the image specific data type. After that, what we can do is that we can go with cv.drawContours, pass in our canvas, and also pass in our contours list, which is stored inside the contours variable, and then go with the value -1 for all the contours. And then for the color, let's go with green color, so 0, 2, 5, 5 and 0. And then for the thickness, let's go with the thickness of 1. After that, we can do cv.imshow, and then in here we can pass in our canvas image, but before that I'm going to call my window as contours and then canvas. So now let's save our program and execute it, and we get the following output. So as you can see, in this image we have much more clearer contours. So that is how you can combine thresholding or adaptive thresholding to find much better contours of your image. Now to finish off this section, I'm simply going to comment this whole area out, and then I'm going to copy these lines as well and comment this out. Now I want to try out the other method for mean detection. So I want to go with adaptive thresh Gaussian C. With this, I can simply run the same exact lines and have a different output. So let's compare the output. So save my program and execute it, and I get the following output on my screen. So as you can see, this part over here is a little bit weird. This is because we are using a Gaussian filter on top of our image. Now to compare this, we can uncomment this out and simply give a different name like this. Let's call it image2 and pass 2 over here as well. So this time around we have two different images. So this is with the mean C threshold and this is with the Gaussian C threshold. So that was all about thresholding with OpenCV. Anyways, this section is going to be all about edge detection. So by far, let me just do import cv2 as cv. So by far we have used this function, which is the canny function, to fetch the edges of grayscale images. But the thing is that this canny function is not a basic level edge cascading function. This is a very advanced level function. Now this canny function includes a lot of steps. The first step is a Gaussian filter. The second step is to find the intensity of the gradient of the image. Now gradients are also edge-like regions, but they are very different from edges. Now it is the same case as it was with contours, that they can be misunderstood easily for edges. So what happens is that when you're trying to convert the value from black to white or white to black, it does not usually convert it as 1 or 0. It is changed in sort of an increasing curve value. So to represent that, we have gradients. So that is why we need to find the intensity of the gradient of the image. And then for the third step inside this canny function is the gradient magnitude thresholding, which is also known as the lower bound cutoff suppression. After that, the fourth step is again double thresholding, and at the very end we have edge tracking by hysteresis. So those are the 5 steps that are performed in the canny function, and each individual step is an advanced level step in this function. So in this section we are going to focus on the different ways of finding edges apart from the canny edge detection. So the first way is to use the canny edge detection, and we have already gone through that. So let's go with the different approach, which is the Laplacian approach. So in Laplacian approach we need an image. So image And then I'm going to simply gray out the image. And then we need to create a variable to store the Laplacian image. So I'm going to call it lap image. And we're going to pass it into the function which is cv.Laplacian. Now this Laplacian function takes in two arguments. First is the original image or the source image, which in this case is our gray image, and then it takes in a d depth which is known as the data depth. So you can go with any depth, but we have some CV constants. So this one is cv dot and capital CV underscore 64f. This is one of the most used ones. Now what this function does is that it converts this image into particular gradients. Now we know that an image cannot exist in the form of gradients alone, so we need to convert that into a particular image data type. So for that we use np.uint8, which is a format for images, and then we pass in np.absolute, and in there we pass in our lap image. And since we're using numpy, so I'm going to do import numpy as np. So what this does is that, so when we get values in gradients, this absolute converts them into absolute values, because gradients values actually can range from positive values to negative values, but an image or a pixel in an image cannot have a negative value. So that is why we use the absolute function to get rid of that negative value. And then we convert that result into the image format, which is the uint8 or unsigned integer 8, which is specific for images. After that, what we can do is that we can go with cv.imshow and display the result as Laplacian result and pass in our lap image. And at the end we know we have to go with the CV wait key 0. So save my program and execute it, and I get the following output on my screen. So this is the Laplacian result or Laplacian edge detection. So we can change the picture, we can go with the city picture and rerun our code. So as you can see, this is a very accurate representation of all the edges and gradients in an image. So let's put it up against the canny edge detector as well. So in here I'm going to create a canny variable and set it equal to cv.canny, and in here I'm going to pass in my image, and for the threshold I'm going to go with 125 and 175, and I'm going to go with cv.imshow canny result and pass in my canny variable. Save my program and rerun it so I can compare the results with canny and Laplacian. So this is our Laplacian result, whereas this is our canny result. So as you can see in the canny, in this particular building right here, you can see that the edges are a little distorted, and in the Laplacian one, these edges are really smoothed out. So Laplacian is also a really good edge detection tool. However, Laplacian is not actually as precise as canny, because in canny, in this step where we have to find the intensity of gradient, we are already using the Laplacian edge detection. Anyways, in OpenCV we have a third edge detection as well, which is known as the Sobel edge detection. Now basically the Sobel one actually works across either the y-axis or either the x-axis. So you need to have two different variables to get both of those axes. So I'm going to create a variable, I'm going to call it xsobel, and I'm going to set it equal to cv.sobel, and in here we're going to pass in our grayscale image, and then we need to pass in our depth, so we know that is cv.cv underscore 64f, and then we pass in 1 for the horizontal axis and 0 for the vertical axis. And similarly we can simply duplicate this line and change it to 01 and change the name from xsobel to ysobel, and then we can do cv.imshow. We can go with xsobel, and similarly we can go with the ysobel. But since this picture is quite big, I'm simply going to resize this image. So with this, I should be able to get all of the results on my screen. So save my program and execute it. So let me just rearrange these. So this was the canny result, and this is the Laplacian result. So this is the xsobel and this is the ysobel. So you can see in the xsobel, the lines or the gradients that are drawn are across the x-axis. They are not in the direction of x-axis, rather they are across the x-axis. Similarly for y-sobel, as you can see that the gradients are across the y-axis. We can combine both of these x and y sobels to get a combined sobel result. For that we would have to use the bitwise OR operator. So I'm going to call this one as sobel, and I'm going to set it equal to cv.bitwise OR, not ZOR, it's actually OR, and I'm going to pass in x sobel and y sobel. And then I'm going to go with cv.imshow and call it combined sobel and pass in my sobel variable. Then I'm going to save my program and execute it to get the result of combined sobel. Anyways, so this is the Kenny edge detector, which is by far the most precise one. Then we have the Laplacian edge detector. Then we have x sobel, y sobel, and then with the use of bitwise OR operator we have the combined sobel for edge detection. So those were all the techniques that are available in the OpenCV library. Although with the contribution from the community there are a lot more functions that can help you detect better edges, but you can explore them on your own. So that was it for this section. Okay, so in this section of our course, we are going to implement a very basic project using the OpenCV and using the live webcam feed. So the project is that we are going to recognize colors that are on a specific place on our video feed. To save our project from this mess, I'm going to create a new folder and call it projects. And in this folder, I'm going to create a new file and I'm going to call it color Recognition.py. So in this project, some of the things are going to be new and most of them, around 95% of the things, are going to be the old one. So let's start off. So the very first thing is we need to import the CV2 library as CV. After that, we want the feed from our camera. I'm going to go with video_capture as the variable for my video feed, and we're going to use the function CV_video capture. And since I'm going to be using the webcam on my laptop, so I'm going to go with 0. Remember that if you're using a different camera that is connected to your PC, then you want to change the values according to that camera. After that, I want to set the feed or resize the feed from my camera, so I'm going to go with video_cap.set, and then I'm going to use the word 3, my width, which is 1280, and I'm going to copy it, and I'm going to go with 4 and go with 720. Now we know how to get the feed to be displayed onto the screen. So create a while loop and pass in true, and in here create variable like success and pass in my frame and set it equal to the video cap.read. So this is going to read frame by frame. Now after that, I can do IMShow. Actually it's cv.imshow, and in here I can go with camera feed and pass in my frame in this one. And then I can type in if cv.wait key, pass in 1, and 0xff is equal to the order of a particular key press, which I'm going to type as x. Then break, and then come out of the while loop and do video cap.release, and then go with cv.destroy all windows. So that should give us a camera. So now if I run my program, I get my camera feed on my screen, and the frame is set at 1280 by 720. I also want to do one more thing. I want to flip this frame. So I can go with frame is equals to cv.flip, and I'm going to pass in my frame, and I'm going to flip it across the y-axis. So do that, and then I'm going to read on my code just to verify it. So yeah, that's more better. After that is done, now I can start working on how to recognize colors. So what I'm going to do is that I'm not going to work with the BGR scheme or the RGB scheme. I am going to work with the HSV scheme. Now HSV stands for hue, saturation and value. So to create the HSV frame, I'm going to call a new variable, call it HSV frame, and set it equal to, now we know how to convert colors, so that's cv.cvt, and pass in my original frame, comma, and for the color I want cv.color, and the color is BGR to HSV. So this should give us our HSV frame. Now what do I want to do exactly? So let me just run my code and let me just show you. So what I am going to do is that I'm going to specify a region in the center by a circle or a rectangle, and any color present inside that would be recognized by our program. So I want to find the middle point of this live video feed, and I want to put a circle or a rectangle there. So let's try getting the center points. So I'm going to create a variable like center x is equals to integer, because this is going to be an integer, and I'm going to get the width divided by 2, and I'm going to do the same with height, so HIGHT, and change it to center y. So currently I do not have those variables width or height. So what I'm going to do is that I'm going to create the height variable along with the width variable, and I'm going to get the values from my frame.shape. I do not need to specify which index I am working with the square brackets, because I am going to use both of them, which is the height and the width. So that is how we can find the center of the screen or the video feed. Now I want to get the centermost pixel, and I'm going to call it my point of recognition, POR, or pixel of recognition, and I'm going to set that equal to my HSV frame. Remember, I'm going to get that particular pixel from the HSV frame, not from the BGR. So HSV frame, and the value is exactly center x, it's actually underscore x, and center y. So this pixel POR is going to be the pixel on which we are going to check for the colors. Now in HSV scheme, if I go with POR and 0, this will mean the U value. Similarly, if I go with the 1, it would mean the value of saturation. And then for POR or the index at 3, this would mean the value. So basically, we want to know what are the values for different colors, what are the HSV values for different color, and then we can compare the value on that particular pixel, which is our POR, against that particular value that we have defined. So we know that we are going to need a variable, so we're going to create a variable and going to call it color, and I'm going to set it equal to undefined for now. And let's just go to Google. So I'm going to head over to Google, and in here I'm going to type in HSV color picker. So I have two options like color picker online and this one, and in both of these you can set saturation to 100 and value to 100. Let's see what this is. So I'm going to set the saturation at 100 and the value at 100, and then I can play with the U. So if my saturation is 100 and my value is 100, and if I move the hue value from 1 to let's say 5 or 6, it stays red. After that, it starts to shift to orange. Let's see where till orange goes. Orange goes around. It's totally up to you on how much precise you want. After that, we start getting yellow. And after that, we have green, kind of a teal color, blue, purple, violet, and so on, back to red. And back to red. So that is our HSV. And if I simply drop down the saturation value to 0, that is white. So I can go with that. If my saturation value is below, let's go with below 8, then that would mean that the current value is white. Similarly, if I increase the saturation to 100% and simply drop the value to 0, that would give us black. So I can go with that if the value is below 16, that is black. So let's try to code that out. So I'm going to create the first value as U value is equals to POR and the 0th index. Then I'm going to go with saturation value, set it equal to POR and the first one. And then I'm going to go with the value, but that is going to become confusing, so I'm going to name it the V value, set it equal to POR, and then now it's all about if statements. So let's start off. So if my saturation, sorry, it's not saturation, it's if my sat value is less than 12, in that case color is equals to white. Now elif my v value is less than 10, in that case my color is equals to black. And let's talk about different u values. Let me explore. So I want black to be up to 13, so I'm going to change this to 13, and I'm going to change the saturation to 10. Let's do 10. So again I'm going to add in another elif and say that if my u value is less than 5, or go with 6 or 7, then the color is equals to red. And then elif, if my u value is less than 22, then my color is equals to orange. Then move on, elif, if my u value is less than 33, then my color is equals to yellow. And then elif, u value is less than, let's just go with something like, let's check it out actually. So after yellow we have green. I changed the values a little bit because I wasn't satisfied with them. So if it is less than 80, then we can go with color is equals to green. Then we can go with like elif, if u color or u value is less than, let's just go with 135, the color is equals to blue. And then elif, u value is less than 175, then that is color is equals to violet. And then by default, if you come back to this one, if you see, it starts from red, and as you increase the u value, at the end it becomes red once more. So we can say that else, if the value is greater than this, then color is equals to red. And I also forgot to put the circle at the center point, so let's do that first. So cv dot circle, and I'm going to put it at frame, not the HSV frame, because we are showing frame on the screen. And then we are going to find the center. So we know that the center is at center X and center Y, and I want a radius of, let's say, 5 pixels, and then color, let's go with a white color. So let's go with 255, 255, 255, and then thickness of, let's just simply go with 1 and save our program. Let's do this one thing. Let's simply check right over here. Let's type in print color. So this is going to print the color onto the terminal. So save my program and execute it. It's actually not after the break statement, it's over here. So print color. And then before running it, actually you need to put in a third variable for the shape, because this shape is in 3 layers. So type in any random trash variable. So I'm just going to name it as XYZ for 3 layers, and then I can simply save my program and finally execute it. And on my screen I get the following output. Even though I don't see the circle, but I'm going to fix that. But I'm getting the output as red. I don't know, okay, this is changing values as I move my hand across the camera. So it is picking some kind of value, so we'll figure that out. Okay, the problem was that I was showing the frame before doing anything, so I need to cut this line from here and I need to place it right before my break statement. So now I can simply remove this line. Then I can also get the center pixel of the screen as POR, or I can just name it center pixel CP, and this is going to be in the BGR format. So I'm going to set it equal to the frame, and we get the center X and the center Y. And then I'm going to simply destruct this object or this array into individual BGR values. So integer, and then I'm going to call it CP BGR. This is actually CP BGR and 0. And then I'm going to copy it, put a comma, paste it and change it to 1, and then paste it once more and change it to 2. After that I want to display a square on which I'm going to print out the text telling us which color it is. So for that we have cv.rectangle, and in here I'm going to pass in my frame, and to start the rectangle I'm going to take the center of x, and I'm going to subtract something like 220 and 10, and for the ending point it is going to be c of x plus 200, 120. Now for the color, I'm going to get the color as white. After that I want to display text, so cv.putText, and in here I'm going to pass in my frame and the color variable, which is this variable. So I'm going to take the words from here, color variable, and then I want to place it at exactly that point. So it is going to be center of x minus 220, 100. And for the font phase I'm going to set it equal to 0 and scaling to 3, and then I can simply pass in my bgr array as color. So what this bgr is going to do is that it is going to color that word according to the pixel value at the center. And lastly, I'm going to give it a thickness of, let's say, 5. And then I'm going to again show my circle at the very end. So cv2 circle, it's going to be on the frame at the very center of the screen, so center x, center y. The radius is going to be 5, the color is going to be something like 30, 30, 30. Last time I chose 255, so that is why the color became white and I was not able to see it. And I'm going to set the thickness at something like 3. With that, I should be able to save my program and execute it. So save my program, and this is center y. Let's actually check for some errors. So I did actually make a mistake. The thing is that when you're trying to get the central pixel value, you need to pass in the y value first. So y first and x later. Same goes for the HSV frame, you need to pass in y first and x later. After that, save your program and execute it. So now our program is running. So you can see this black dot right over here. This is going to be the one where we pick the color. So it is currently showing orange because I have not concisely selected the colors. So let's check with red. So I have this bottle, or the bottle cap is red, so it changes to red instantly. And then I can go with something like green or blue. I have this ball pen, so it's showing me as it is blue. And then, okay, sorry for that noise. And then I have this artificial plant, so if I put in the leaves, it shows green instantly, then much more darker green. And I don't have anything yellow to show it to you, but I have this air freshening can, so it shows you a little bit of orange and yellow, and the part where we can see the reflection of the light, it completely disappears because it is currently white, and color white cannot be displayed on the white background. So we can assume that our white recognition is also working perfectly. So that was the color recognition in OpenCV, and this was a very basic implementation of OpenCV. Make sure to test out your logic building capabilities and come up with much better projects. So that was all for this OpenCV beginner to intermediate course, in which we covered everything that was important. We might not have mentioned some topics like color spaces, color channels, but be assured that we do have covered them. And after practicing this course like 2 or 3 times and coming up with your own examples, you should be sure of yourself that now you are pretty good in OpenCV in Python language. And that's it.